Hi viewers, welcome to my channel. In this lecture, we'll discuss about RDDs, Spark RDDs. In our previous sessions, we have discussed about Databricks architecture, how to create data frames. Okay. Why will we go ahead with the data frames? How many ways we can create data frame? All those things we have discussed. In this lecture, we'll discuss about Spark core. That is the main layer in the Spark ecosystem. Data frame will be created on top of RDD, right? So we need to, in this session, we will discuss about the RDDs, how can, what are the features of RDDs, so why, what is the internal mechanism RDDs, all these things. So in real time, we will use data frame approach and data sets only in the business logic implementation, but rarely we will use RDD because RDD is very important. RDDs are a bit slow, but we need to understand the internal mechanism of RDD to understand Spark or Databricks in a better way. Okay, so this is the Spark or Databricks ecosystem. So main layer is a Apache Spark core, that is RDD. So data abstraction in a Spark core is a RDD. For example, what is data abstraction means that is what a data unit called as a Spark RDD. Okay, Spark core RDDs, Spark SQL data frames, and data sets. So if we see this diagram, so this is the main in processing engine is a Spark core, that is RDD. On top of that, we have a Spark SQL, Spark Streaming, machine learning libraries, graphics. Okay, so below layer is a first one is a, this is a cluster manager. So if you refer our previous videos, so in that architecture, we have discussed about cluster manager, right? So we have many cluster managers. Important are four cluster managers. One is a Kubernetes. If we were you have created a Databricks. We are using Databricks in cloud and containerization. We are doing that time. You can use a Kubernetes as a cluster manager. Okay, if you are working on Spark RTDs on if you are working with Spark core on Hadoop ecosystem, then cluster manager is Yarn. Okay, so if you are working on Azure Databricks or uh, Databricks, that will be standalone cluster manager is a cluster manager. So this is the basic ecosystem of Databricks or Spark. If you write any Spark SQL code or Spark streaming code, machine learning libraries code, graphics, everything, internally it will be converted to the RDDs and the actual execution. Then that RDD will convert it into bytecode. That bytecode will be executed in the executors of the cluster. Okay, so this is the main processing engine of Databricks or Spark. So now we'll go ahead with the what is RDD. RDD is nothing but a resilient distributed data set. Okay. RDD is as discussed earlier, how we will deal with the tables in the databases. Same way, RDDs we will deal with in Spark core. Okay, all the Spark ecosystem is built on top of RDD. Okay, and Spark SQL, machine learning library, ML, MLib, Spark streaming, everything is on based on it will work based built on top of RDD. Okay, so resilient. The first letter is R, right? R is nothing but resilient. That is resilient, nothing but able to recover in a failure conditions. Okay, and also RDDs are immutable and cannot modified once created. So resilient meaning here is if a failure happens, we can recover the RDDs. Okay, and in resilient, one more important concept is fault tolerance. How we will recover the data using the fault tolerance. Fault tolerance is the capability to operate and to recover loss after failure occurs using RDD lineage. Okay, so how we will recover the failed RDD using RDD lineage graph. So once you create a RDD, so for example, in a program, if you have some 3 4 RDDs, this lineage graph will be formed and it will represent the link between one RDD to another RDD. What is the link? All this it will manage. Okay, something happened, something on RDD is failed, data is lost. Again, we can uh, uh, recover using this lineage graph. That is nothing but a fault tolerance. Next letter is a distributed. So it is a whatever that RDD will be divided into smaller chunks called as partitions, and that partitions will be distributed across the multiple nodes. Okay, across the cluster. Okay, all this Spark and Hadoop these are distributed architectures, right? Once you load or read the data into RDDs, that will be divided into part number of partitions and it will be distributed all the partitions across the cluster. Okay. Default partition size is 128 MB in Hadoop ecosystem. In Databricks also same, but you can change using some properties configuration commands. You can change. By default, it is a 128 MB. For example, if you read 300 MB file, it will be divided into 3 files. Okay. Okay. For example, 300 MB file will be divided into 3 files. Okay. If block size is partition, each partition size is 128 MB, right? So in 300 MB, how many 128 will come up? Two 128 MB will come. Okay, that is two partitions. Remaining leftover 44 MB, it will be created as a one more file. So totally 3 files. It will be three. It will be that file 300 MB file will be divided into 3 partitions. Okay. So third D is a data set, which is holding the data. Data is nothing but holding the data. So RDD is nothing but a resilient distributed data set. So what are the features of RDD? So RDD has some more specific uh, default features. First one is a fault tolerance. Second one is distributed. Third one is lazy evaluation. Fifth one is immutability. Sixth one is fourth one is immutability. Fifth one is in-memory computation. And last is it will handle all types of data. Okay. This we will see one by one in upcoming video. We'll see all the features. Okay. What is fault tolerance? What is distributed? Lazy evaluation, immutability. So we need to understand all these features to understand Databricks completely. Okay. In term, while working in the real time, it will not use in the coding part RDDs mostly. 90% will use data frames only. But if you understand the architecture of internal mechanism of RDDs, then it will be easy for the optimization of Spark or Databricks. Okay, that's all in this lecture. We'll see RDD features in upcoming video. Thanks for watching.